After my last video on the architectures, the network architectures from 2G to 5G, many people came back to me asking what about NSA and SA? Don't worry if you don't know what NSA and SA stands for. We will look into this particular video. But these are the kind of questions that came to me. So I thought let's make this particular video looking at the architecture specified for 5G and which is being developed. If you have not yet looked at this presentation, the high level architecture from 2G to 5G, and if you're not aware of how the architecture evolved from 2G to 5G, you may want to look at this particular video. You can click on this link uh, to check the video out. So last year, Deutsche Telekom they proposed different architecture options, uh, and all these architecture options were individual architecture options proposed by different companies. They collected them all together and presented it as a single document listing out all the different options, and this document has formed the basis of all the different architectures that are being discussed. If you want to look at the document, you should be able to click on the link and you should be able to actually go to the slide share presentation where this document is available to download. So from that Deutsche Telekom's presentation, option 1 is the standalone LTE, which is EPC connected legacy architecture, right? This is the architecture which I'm sure most of you know about. The non-standalone NSA architecture that is being proposed as this is being proposed as the initial architecture which would be released in phase 1. Now the phase concept has gone a bit fuzzy, so I'm not going to refer to as phase 1 and phase 2, but this is the initial architecture and the first 5G documents that will be released later on this year is looking at this particular architecture. Now as you can see, there are two options, option 3 and option 3A. This particular representation right now is the option 3. So the new node B, right, which is the G node B, G stands for next generation node B, right? In LTE we had E node B, which was evolved node B, evolved from the 3G node B, but in this one we have G node B, the next generation node B. Now as E node B we would refer to it as LTE, G node B we refer to it as NR, new radio, right? So no long-term evolution, but instead we have new radio, NR. So this is option 3 where the E node B is connected to EPC, so you have the control plane and the user plane, and the G node B is connected to E node B, so the G node B's control and the user plane goes via E node B. When we talk about option 3A, you have connectivity for user plane from G node B directly to EPC. So that's the only difference between option 3 and option 3A. These different approaches are available for vendors and operators to decide which architecture suits them better. So this particular option, the non-standalone LTE assisted option 3 and option 3A architecture, it leverages the existing 4G deployments. It's capable of creating 5G hotspots quickly, and the EPC is not overloaded with 5G signaling. 5G new 5G applications and services creation is possible. Now this particular option is option 2. This is the standalone architecture, right? So you have the G node B connected to the next generation core network. So you have the new control plane and the new user plane, which is the next generation control plane and the next generation user plane. So this option would be perfect for the greenfield 5G operators. So what I mean by the greenfield 5G operators is that there would be some new operators who would actually bid for the 5G spectrum, and they would buy the spectrum, and they would want to deploy a 5G network, but they do not have a legacy 4G network, so they cannot use those options 3 and 3A which we just saw. They can only do this particular deployment. So next generation core network connected to the G node base. So this is perfect for them. And this particular option gives full support for the new 5G applications and services, including enhanced mobile broadband, massive machine type communications. Now the machine type communication, if in case if you don't know, is basically the 3GPP term for M2M, machine to machine. Okay, so you can have massive machine type communications and also ultra reliable and low latency communications, URLLC. But the thing to remember is for 5G to be ubiquitous, you want to have the operator would need multiple spectrum to be able to provide all of these above use cases which I've listed above, the EMBB, massive MTC and URLLC. In my earlier presentation on spectrum, which you should be able to actually click the link here, uh, I mentioned that for 5G, it an operator would need multiple layers of spectrum. So ideally a sub 1 gigahertz, or some people are now talking about sub 2 gigahertz frequency, which will be the coverage layer, ideal for all these massive machine type communications. Then you have the capacity layer. The capacity layer would provide like a high throughput, but also have sort of like a good coverage. So this could be used for the ultra reliable low latency communications, as well as for enhanced mobile broadband. uh, and then finally you have a high throughput layers, which would be like hotspots, and there a lot of users could be served with very high throughput. So an ideal combination would be an operator needs all of these three particular spectrum, three layers of spectrum, to be able to provide all services in a perfect way, perfectly possible way. So the next option is the evolution architecture. So this is again non-standalone evolution architecture, and this is option 4 and 4A. So this particular option which you see is option 4. So the E node B connects to the G node B, so the control and the user plane, and the G node B's control and the user plane connects to the next generation core network. Option 4A, in case of option 4A, the E node B's user plane would connect directly to the next generation core network. So as you can see, the next generation core network has replaced EPC. Uh, so 5G driven by capacity needs rather than just coverage is the reason for deploying this particular option. New 5G applications and services creation possible. In case there is another option, so the non-standalone new radio assisted option 7 and 7A. So the last one which we saw was option 4 and 4A, and this is 7 and 7A. Now in this case, as you can see, the main difference is the E node Bs are connected to the next generation core network rather than the G node Bs, and the G node Bs are connected via E node B. Okay, so this would be option 7. In case of option 7A, the G node B would have the user plane to the next generation core network. And some people wonder why this particular option would be needed. So the main reason why an operator might deploy this particular option is, so you do not have to do massive changes to the existing network. So as soon as the next generation core network is introduced, you replace the core from EPC to next generation core networks, and all your other interfaces and routing tables and everything remain the same. So it's just the core network which has been changed from EPC to next generation core network. And then when you are introducing the new G node Bs, you can actually connect the G node Bs via E node B. So I have a feeling that actually in the non-standalone new radio assisted, we might actually see this option being more popular than the other option, the 4 and 4A. Again, this will give the same benefits as option 4 and 4A. Recently, in a presentation around 2 weeks back, the chairman of 3GPP RAN presented this particular slide. Now, the important things to note in this particular slide are, so the first release or an early drop will come in December of 2017. The focus will be on LTE anchored LTE new radio dual connectivity. So this would be option 3 and 3A, right? So this is the focus initially in the first drop of option 3 and 3A. And in June of next year, in 2018, a full release 15 standalone new radio with new 5G core network. Okay, so the focus would be in next year, in June 2018, we would have the option 2 deployment available, and then later on we will actually in the standards and in the specifications look at option 4, 4A, 7, 7A. So this was a quick tutorial looking at the 5G deployment architectures. Hope you found this useful. As always, please feel free to leave your comments and suggestions in the comments box. Thank you.